Hello and welcome to Lecture 8 in the Intro to Python video series. In this lecture, we will delve into tuples and sets, two essential data structures in Python. Tuples are ordered collection of elements similar to lists, but with a twist. They are immutable. This means once you create a tuple, you cannot change its elements. So a tuple in Python consists of a number of values separated by a comma. Let's take a look at an example. So you can do something like t equals 1, a, true. And if you print t, you will see that we have created a tuple t with three elements, an integer, a string, and a boolean value. When creating a tuple, the parentheses are optional, so you could have done something like t equals 1, a, true, and if you print t, you will see that you get exactly the same result as if you had included the parentheses. You can access tuple elements using indexing and slicing just like you did with lists. So you can do something like t of 0 to access like the 0th element within the list. You can also slice a tuple, so you could do something like t of -2 : to get the last two elements from the tuple. So as mentioned earlier, tuples are immutable, so you cannot change their value once you've initialized them. So if you try to do something like t of 0 equals 10, then this will give you an error. So let's try running this, and you will see that tuple objects does not support item assignment. This basically tells you that once you create a tuple, you cannot change the value that it was initialized with. Tuples can contain another tuples, allowing for nested structure of tuples. So you could create a tuple x, which contains t, and some other tuple that contains 10 and 20. And if you try to print x, you will see that now x is a tuple of tuples, where the first one is a tuple t, and the second one is a tuple containing 10 and 20. Unpacking tuple allows you to assign their value to multiple variables at once. So we have our tuple t, and then we can assign each of the elements within t to different variables. So you could do something like a, b, c equals t. And then if you print each of these variables using something like this, then you will see that a has the value 1, b has the value a, and c has the value true. So this statement here basically assigns each element of the tuple to the variables a, b, and c. So not that we see tuples and lists, they are mostly similar, but with the main difference being that tuples are immutable. So the question naturally arises when to use tuples. So it's generally advised to use tuples when you have a collection of elements that should not change or should be immutable. And tuples are often used for returning multiple values from a function. So let's say we want to write a function that returns the sum and the difference between two elements, a, b. Then you could do something like return a plus b, a minus b. So this basically returns a tuple. So note here that the parentheses are optional when creating tuple, so we don't have to explicitly specify the parentheses. So we can just return a tuple where the first element is sum and the second element is the difference between the two elements. Then you can call this function out equals sum and difference with two elements. And then if you print out, you will see that out is a tuple that contains the sum of the two elements as well as the difference of the two elements. You can actually also unpack the results directly, so you could do sum, diff, and then you could print out the sum and print the difference separately. So here what we're doing is we're unpacking the tuple into two variables, sum and diff. Now let's move on to sets. Sets are unordered collection of unique elements. Sets can be created either using curly brackets or the set constructor. So you could do something like set1 equals 1, 2, 3. And then if you print set1, you will see that set1 contains a set that has the elements 1, 2, 3. Another way of creating is using the set operator. So if you call something like set2, you could call the set function on a list of elements 1, 2, and 3. And then if you print set2, you will see that you again have a new set that consists the elements 1, 2, and 3. The argument to the set function just has to be an iteratable, so it can also be a string. So you could do something like set3 equals set a, b, c. So a string, like a list, can be indexed into, and it's a sequence. So if you do print set3, now you'll get a set that contains the element b, c, and a. So one thing to note here is that sets are unordered collection. So even though we specified a, b, c, when you print out the set, the order doesn't get preserved. So you get something in a different order. So here we have BCA instead of the originally prescribed order ABC. And one property of sets is that only unique values are stored in sets. So sets automatically remove any duplicate value. So if you try to initialize a set, let's say set 4 equals, let's call apple, comma, kiwi, comma, and then specify apple again. And then if you try to print set 4, you will see that it only contains 2 elements, apple and kiwi, with the second apple automatically removed from the set. You can add and remove elements from a set easily. So you could do something like set 4.add. Let's add orange. And then if you print set 4, now you have a set that contains 3 elements, orange, apple, and kiwi, where our original set had just the apple and kiwi in it. You can remove an element similarly by doing set 4.remove, and let's call kiwi, and then now if you print set 4, you will see that it only has 2 elements, orange and apple. Sets in Python support various operations like union and intersection. So let's say we have 2 sets called set 1 and set 2, then you can get the union set, which is the combination of the 2 sets, by doing something like set 1, then the pipe symbol followed by set 2. The pipe symbol gives you the union of the 2 sets. So now if you print the union set, you see that it contains the union of the 2 sets. So it contains the elements 1, 2, 3, 4, and 5. Note that 3 occurs twice, and set automatically removes any duplicate values. You can also get the intersection, so you can get the intersection set using the AND operator. So you could do set 1 and set 2, and if you print the intersection set, you will see that this set contains the common elements between the 2 sets, which in this case is 3. Finally, frozen set are immutable version of set. This means that once you create the set, you cannot add or remove elements to it. So you can create a frozen set using the frozen set method. So let's call set 5 equals frozen set, and maybe the set has elements 1, 2, and then if you print set 5, you will see that it prints frozen set and then a set containing elements 1 and 2. Now if you try to add some element to it, so if you try to do set 5.add, let's say the number 5, then you will get an error. So the error basically here says that frozen set object has no attribute add. This is because frozen sets are immutable and you cannot add or remove objects from it. So let's look at when we might want to use set. So you want to use set when you need to store unique elements and perform operations like union and intersections. And sets are particularly useful for removing duplicate elements from list or for checking memberships efficiently. So membership checking isn't something we have discussed before, so let's take a look at what that is. So let's take a look at what membership test in Python is. So membership test is a way for checking if an element is present in a sequence such as string, list, tuple, or set. And we can use the in keyword for doing a membership test. So let's consider a set, let's call it set 1, and then we can check if elements are present in this test. So let's say we want to check if 1 is present, so you could do something like 1 in set 1. And then running this will return true because 1 is present in the set. So if we were to replace 1 with 10, and if we check 10 in set 1, then it will return false because 10 is not present in the set. You can do the same with lists. So if you have a list called mylist equals 1, 2, 3, and then you can do 1 in mylist, and then it will return true. And if you did something like 100 in mylist, then it will return false because 100 is not present in this list. So you can do the same thing with tuples and strings. So with strings, you can use this to check if a substring is present in a string. So let's say we have something called x, which contains hello there. And then if you want to check if hello is in the string, so you can do something like hello in x, and then this will return true because hello is a subset or a substring of this string hello there. So the in operator returns true if an element is in the list or set or string, and it will return false if it is not in the sequence that you're checking it against. So as mentioned earlier, sets are particularly useful when you want to check for membership efficiently because they offer fast membership checks as opposed to list, strings, or tuples. That's it for this lecture. Thank you for watching and see you in the next lecture.